Hello, everyone. D. Alfred Ostrowski. In this recording, I'm going to be expanding on my theory of computation lectures. In this presentation, I'm going to make reference to what is known as the blank tape problem. And on a general level, I'm going to be looking at what we refer to as problem reduction, perhaps a concept that's even vastly more important than this particular problem, this being an example of it and how the research community in general operates, and the premise behind the classification of languages and the basic concepts that have been presented in theory of computation, and how it's applied to areas such as natural language processing, generative AI, compiler development, and so forth. So here I want to talk about blank tape problem. It's not going to be very long. Again, just want to go through some of the basic concepts involved. And perhaps the most important thing is to why this is important. Okay, so let's do that. So if you haven't watched my presentation or studied or read what we mean by the limits of computation, the term recursively enumerative countability, diagonalization, or the halting problem, most importantly, it's in your best interest to do that. This will make a lot more sense if you do. Okay, familiarize yourself. Doesn't have to be my content. You can get it from anywhere. Okay, so but that will allow for a sense of consistency. So let's get on it. Here I'm making an assumption. All right, that I have what is known as a machine known as a blank tape machine. So this is going to take a Turing machine as input. Okay, similar nature to the halting problem, and it's going to take a blank tape. Okay, as what do I mean by that? Okay, so the term tape is reminiscent of some of the earliest forms of information being stored on a computer. So, which we used to have punch tape back in a long, long time ago. Even before that, they had paper tape. Okay, that's why they use the references to tape with the Turing machine and so on and so forth. But the question here is that here's another problem, a variation of halting problem, is that if I have this input into a machine, can it give me the associated output? Okay, so here I have a Turing machine and essentially no input. Okay, and here I have an accept, rejector, or loop. Okay, here's the premise here that, again, what's really killing me is this loop. If I read no input on an application and it goes on and on and on forever, okay, what exactly is wrong? Okay, does this lack of input, okay, is that, or the empty set, whatever you want to describe it, is that part of my language or not? It can loop forever. We just don't know. We don't know what the output's going to be. Okay, so I can assume in similar nature to the halting problem, right, that I have a blank tape machine and it's going to have an accept or reject on the Turing machine, and any given machine, and the blank input. Okay, so I assume I have an input. Okay, so You see where we're going here. We're building up a similar premise. We're assuming that we do have a solution to our problem, and then we're going to prove by contradiction. Okay, so let's continue the thought. Okay, we'll bring up a new screen here. Write this out. So here I'm going to take the blank tape problem and I'm going to reduce it to the halting problem. Okay. So if you recall, a halting problem took Turing machine and some type of input, and it told me whether, and we know that it's not true, and if you don't believe that or you don't completely understand that, go back and review that portion. I don't want to completely rehash it, right? So here I'm going to make the assumption that I have, again, I'm going to duplicate this again. I'm going to say I have my, I'm going to make this a part of a, I can call B or BT blank tape, okay, and it's going to take my my input here, and it'll be definitively giving me the accept. I hate to use that term accept, right? I should say yes or no, okay, that it halts, it doesn't halt, okay. Not halt, okay, or no. I make this a part of a bigger machine, and I can build a conversion device here, right? So this is going to give me the means of having a Turing machine and a given word. And what's going on here? Okay, what is machine C? That is a subsection of the larger machine. Okay. Machine C, and that's where I'm going to have Turing machine on the word. It's going to give a single output. It's going to be a conversion machine. It's going to take a Turing machine and the given word on that, and it's going to create a Turing machine that doesn't need any input, that already has the effect of that word being processed in it. How might that look? Okay, well, if I look at a Turing machine, it can be a number of states. And if I take that word, I know that I can duplicate. Let's say it's not accepted. I end up in this state here. I could rewrite this machine with that word to the Turing machine word, and it would be resulting in that state. Therefore, it doesn't need any input. So I can take that, create Turing machine word, and then have blank, but that doesn't come from here. This is the only output of the machine C as my conversion machine. And I'm pretty convinced that I can do that, okay? I can create the state of that input. So what did I just do? I took a Turing machine and an associated word, and I created a Turing machine with the result of that word being processed into it already. So I changed it slightly, ever so slightly, to put it in the state that it would result in. Now I can use that as an input to my blank tape machine, and that's going to tell me whether it accepts or rejects, or halts or doesn't halt. And in doing so, okay, I reduce this to the halting problem. I created a halting machine. Okay. Through the means of converting, I'm able to take the separate question about, well, what about a machine with no input? Well, I know I can write a conversion machine, put a part of a larger machine, and I can convert it into a halting machine. But here's the problem. When we studied the halting machine, what did it tell us? That this machine does not exist. So what did I just do? I converted this problem here into, I reduced it to the halting problem. What do we know about the halting problem? Doesn't work. Okay. It is a paradoxical relationship and disproves my point. So by virtue of that, the blank tape problem is not solvable either. Okay, so and the bigger picture here is not just the fact of the blank tape machine, it's about the approach of relating one problem to another. If I can take one problem, let's say it's scheduling, and I can make a problem similar format and solve that or not solve it, I can directly apply it. That's how the research community works. Okay, that is more important than understanding whether a machine accepts or rejects on zero input. Okay, it's about reducing one problem to another and moving forward with those concepts. Okay, and similar dynamics can be proved with other examples we'll get into, let's say post-correspondence problems and things like that. So I hope this helps. This helps with your understanding. And thanks for listening. Take care. Talk to you soon.